Good morning and welcome to this edition of MathMind series. Today we are going to talk about indices. Indices, the laws of indices and problems concerning indices, their equations and so on and so forth. So please watch the video and leave your comments in the comment section. So indices. Often we see numbers like this: 2 raised to the power 5, a squared, x raised to the power minus 3, etc. These are written in index forms, and any number has two parts in terms of indices. The base, for example, you say a raised to the power x. A is the base, x is the index. Plural is indices. So every number has these two parts, even whole numbers. For example, 12 is raised to power 1. So where 12 is the base and 1 is the index. So normally when we write whole numbers, we don't put the 1 up because we know it is just 1. Okay, so problems can be solved using problems can be solved in index forms, and there are certain things we have to take note of. 2 times 2 times 2 times 2 is the same thing as 2 raised to the power 4. A times A times A times A times A, same thing as A raised to the power 5. These are written in index forms. And to work with this, there are laws to be followed. There are laws guiding the use of this. Okay, before we go to the first law, well, let's get to the first law. Laws of indices. Okay, the first law is a product law. As a product law, and this applies when bases are the same. If they are not the same, this law wouldn't apply. It is this: a raised to the power x times a raised to the power y. This is equal to a. Because they have the same base, you add their powers. Because they have the same base, you add their powers. But something like this, a raised to the power x times b raised to the power y, can't go in this law. So this cannot go in this law. So this is only the one that will go because the bases are the same. For example, a raised to the power 6 times a raised to the power 9 is the same thing as a raised to the power 6 plus 9, which is a raised to the power 15. And if you check it, you see a times 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 a is equal to, count all the a's here, you get a raised to the power 15. This is using it without the law in the expansion form. So there is a law. Second law says it's called the quotient law. And this law talks about x raised to the power a divided by x raised to the power of b is equal to, because they have the same base. It's just like the first. The only difference is the sign, is the operation. X raised to the power a minus 3. For example, for example, a raised to the power 6 divided by a raised to the power 9. This is equal to a raised to the power 6 minus 9, which is a raised to the power 6 minus 9 is minus 3. This is something we will see very soon. The third law is something like this. It's called the zero index law, which says a number with a zero index is something as 1. Okay. A raised to power 0 is 1. Anything raised to power 0 is 1. This whole entity is equal to 1. Let's see how. Assuming we have a raised to power 2 divided by a raised to power 2. We can do this in two ways. If we use the expansion form, we have a times a all over a times a, which is what? This dividing this 1, this dividing this 1. 1 times 1 is 1. You see, when something divides itself, the result is 1. Using the law of indices, we have a raised to power 2. This division divided by a raised to power 2 is equal to a raised to power 2 minus 2, which is what? A raised to power 0. Now, this a raised to power 0 is something, this entity that gave us a raised to power 0 is something that gave us 1. What it means is that, therefore, a raised to power 0 is what? 1. This applies to every other thing. Zero index clause says that anything raised to power 0 is what? 1. The next law is something like this. Number 4. We have the negative index law. Negative index law. The first one, it goes like this. B raised to power minus x. So here we take the reciprocal of the base and change the sign of index. So this is equal to, when we take the reciprocal, that is the multiplicative inverse of b over 1. This is b over 1 raised to power minus x. When we change it, we have 1 over b raised to power x. So you see, the negative sign here is gone because we took the inverse of the base. It also goes this way. X over y raised to power minus p is equal to, take the inverse of this number, y over x raised to power p. That's how it goes. So that's the law. For example, e.g., 2 raised to power minus 3 equals, then the other one, 8 over 27 raised to power, okay, let's do this. This is equal to 1 over 2 raised to power 3. What that is 1 raised to power 3 over 2 raised to power 3. This is equal to 1 over 2 raised to power 3 is 8. This will come in the next law. And the next law is called the common index law. Common index law. The common index law is saying that when you have a power that is common to numbers in the brackets, for example, a raised to power x b all raised to power y is equal to. That means the y here, we open up this bracket and multiply the indices of both. Is equal to a raised to power x times y times b raised to power 1, because this is 1 here, times 1. This is equal to a raised to power x1 times b raised to power 1. It also goes this way: x over 1 all raised to power p is equal to x raised to power p over y raised to power p. So this means that p is common to x and y. That's why it's called the common index law. So I will take one more. We have okay. We have the fractional index law. When I take this, I will take an example that concerns the two of them. Fractional index law. When a an index is a fraction, when an index is a fraction, when an index is a fraction, the denominator of the fraction represents roots, while the numerator represents the proper power. Both of them are power actually. Let's see what we have here. A raised to power p over x is equal to. Now, this is the denominator of the fraction, that is the power. This denominator will become the root of a, which is raised to power p. This can also be written as the root of a, x root of a, or raised to power p. Whether the power is inside the root or outside the root sign, they will give you the same thing. So we get another one, a over b raised to power p over x is equal to x root of a over b into all raised to power p, or x root of a over b everything raised to power p. Okay, so we'll now take an example. What I wanted to write before, 8 over 27 raised to power minus 2 over 3. Here, we are combining three laws also to solve this problem. Solution: 8 over 27 raised to power minus 2 over 3 equals, I would like to change this to a positive index. What do? I take the reciprocal. This is 27 over 8 raised to power 2 over 3. The sign goes. I will do something. Here. I'll break 27 down. When we break 27 down, what goes here is 3 to give you 9. What goes here is 3 to give you 3. Then 3 goes to give you 1. So this is what we will have. 27 is 3 raised to power 3 all over. I'll break it down. Of course, you know that 2 can go to give 4. 2 can go to give 2. 2 can go to give 1. This is 2 raised to the power 3. This is 2 raised to the power 3 all into 2 raised to the power 2 over 3. This is equal to. Now, we go back to the common index law. We can rewrite something like this into this, or this to this. So this will have 3 raised to the power, there's 3 is common. Take it out to come back to this level. When 3 is common, we have 3 over 2 raised to the power 3. That's what we have. This will give you this. Then times the ones outside, 2 over 3. 3 we divide 3 to give you 1. 1 times 2 is 2. So this is what we have. 3 raised to the power. Okay, 3 over 2 raised to the power 2, which is 3 raised to the power 2 over 3 raised to the power 2, which is 3 squared is 9 over 4, which can now be 2 whole number 1 over 4. Or you can move in like this. This is 3 raised to the power 3 over 2 raised to the power 3 all into 2 over 3. Applying that same law, that same common index law, we have this is equal to 3 raised to the power 3. This goes to multiply it times 2 over 3 all over 2 raised to the power 3 times 2 over 3. What do we have? This will cancel this 1. So this is 3 raised to the power 2. This cancels this 2 over 2 raised to the power 2, which is 9 over 4, which is this. So take note. I prefer to solve it this way, but we can also solve it this way. 8 over 27 raised to the power minus 2 over 3 is equal to 27 over 8 raised to the power 2 over 3. What this means is that the root is cubed because of this is 27 over 8 all squared. So what we have, when we take the square root, this means cube root of 27 all over cube root of 8 all squared. Cube root of 27 is 3 squared. Cube root of 8 is 2 squared. I hope you can get cube roots. I believe this is an easier method of solving stuff like this instead of going to rely on cube root and square roots. Okay, that is these are the laws of indices, and okay, let us try these examples. Evaluate. We are applying the laws of indices to solve this now. Solutions. Now, we have the first one, A, 10 raised to the power 2 times 10 raised to the power minus 3. This is equal to, because they have the same base, the law is valid. You have 10 raised to the power 2 times plus minus 3. This plus is for this times, then the minus 3 is still there. This is 10 raised to the power 2. Use plus and open the bracket. Plus 1 times, just plus times minus is minus 3. What do you have? 10 raised to the power minus 1. 2 minus 3 is minus 1, which is equal to 1 over 10. You can go on to say 0.1. The second one, 22n raised to the power 5 divided by 2n raised to the power minus 3. This is equal to. Now, in this kind of problem, we bring the like terms together. The ones with n will come together, and the ones that are just numbers will come together. So what is 22 times n raised to the power 5 all over 2 times n raised to the power minus 3. First of all, 2 can divide 22 here to give you 11, right? Let me write it down. This is 11 times n raised to the power of 5 divided by n raised to the power minus 3. This is what you have. 11 times n raised to the power of 5. This division is minus. The 3 itself is negative. It's 11 times n raised to the power minus times minus is plus. 5 plus 3. This is 11 n raised to the power 8. So you can cut some steps short here. From here, you can easily write that it is 22 over 2 times n raised to the power 5 divided by n raised to the power minus 3. It's easier that way, so that you can get to where we have what we have faster. Okay, the next one, 2 raised to the power minus 2 times 1 over 6 raised to the power minus 1. This is equal to, change it to positive index. This is 1 over 2 raised to the power 2 times, change this also to positive index, 6 raised to the power 1, which is 1 squared is 1, 2 squared times 6. This is what we have, 1 over 4 times 6. 2 can go here, 2 can 3, which is 3 over 2. The answer is 1 whole number 1 over 2. The next one, D. 5 raised to the power minus 3 is equal to 1 over 5 all raised to the power 3. Don't need to tell you that this is 1 raised to the power 3 or 5 raised to the power 3. You know the laws we are putting on. 5 times 5 times 5 is 125. This fifth one, 10 raised to the power 3 times 10 raised to the power 4 is simply the same base, 3 plus 4 because of the times, which is 10 raised to the power 7. F, x raised to the power 2 all raised to the power 3 is equal to x raised to the power 2 times 3, 6. G, minus 3 d squared all into squared is equal to, separate them. This is minus 3 raised to the power 2 times d squared times 2 up here. Minus, this means minus 3 times minus 3. So minus times minus is plus. 3 squared is 9. So this is 3 squared times d raised to the power 4, which is 9d raised to the power 4. Next problem, the next question is number H. 3a squared in all to squared times 3a raised to the power minus 2. This is equal to, these two affect both 3 and a. So this is 3 squared times a, 2 times 2, 4 times 3. This minus 2 is just for a, because there is no bracket 2. This is times a raised to the power minus 2. This is what we have. 3 squared is 9. After this is 3 raised to the power 2 plus 1. The 1 here, if you are bringing the 3's together, times a raised to the power 4 plus minus 2. So this is 3 raised to the power 3 times a raised to the power, plus times minus is minus 2. So this is 27 a squared. I, 2x squared times 2x raised to the power minus 2. This is equal to, bring the 2's together, 2 times 2 times x squared times x raised to the power minus 2. This is equal to 4 times x raised to the power 2 plus minus 2. Plus times minus is minus. So this is 4x raised to the power 2 minus 2, which is 4x raised to the power 0. It is 4 times 1. So this goes to 1. This goes to 1, which is 4. And the last one here we have j 12 times 10 raised to the power 5 divided by 3 times 10 raised to the power minus 2. Bring the numbers together like terms. This is 12 over 3 times 10 raised to the power 5 divided by 10 raised to the power minus 2. This is equal to 4 times 10 raised to the power 5 minus 2. The division here, the minus is coming from division here, and this one is from minus 2. This is 4 times 10 raised to the power 5 plus 2 minus times minus is plus, which is 4 times 10 raised to the power 7. So I hope you got those. So we're going to take more questions. The first one is this. More questions. Now, the first one, 125 raised to the power minus 2 over 3. How do we go about this? Different ways actually, but my preferred way is this. Preferred method is break 125 down. 125. When 5 divides 6, you have 25. When 5 divides 6, you have 5. When 5 divides 6, you have 1. So this is what you have, 5 raised to the power 3 all into minus 2 over 3. Okay, so this is equal to 5 raised to the power 3 times minus 2 over 3. 3 cancel 3, you have 5 raised to the power minus 2, which is something as 1 over 5 raised to the power 2, which is 1 over 25. I am 0.027 raised to the power minus 2 over 3. Look at this. Change this to fraction. Change to fraction. How do you do it? This is 27 over 1000 all into minus 2 over 3. This is equal to 1000 over 27. I want to change this to positive index. Raised to the power 2 over 3. This is the same thing as 1000 is 10 raised to the power 3. When you break it down, 27 is 3 raised to the power 3. Like we did somewhere, all into 2 over 3. So this is equal to 10 raised to the power 3 times 2 over 3. Common index there. 3 raised to the power 3 times 2 over 3. So we cancel 3. We cancel 3. So we have here 10 squared over 3 squared, which is 100 over 9. You can go on and change it to mixed number, which will be 11 over 1 over 9. Okay, there should be more problems, but the last thing we are going to do here today is equations with indices. Equational indices. Equations. So when we have an equation involves undoing what is already there. If you have something like a raised to the power x is equal to b, to find a, what we do is to undo this power. How do we undo the power? Undo the power. How do we do it? We multiply the power by its reciprocal, or inverse, or inverse. That's multiplicative inverse. So this is how a raised to the power x times 1 over x equals, do it to both sides, a raised to the power 1 times 1 over x. So a is equal to, because this will cancel this, so a raised to the power 1 is equal to a raised to the power 1 over x. When you write it well, you have the x truth of b. So this is one way of getting solutions to equations. So we'll just take problems, and with that, we'll see different ways of solving them. So let's see. Number one, 3 raised to the power c minus 1 equals 27. How do we do that? Solution. This is 3 raised to the power c minus 1, 27. Can we make 27 to have the same base as 3? Yes, because we know that 27 is 3 raised to the power 3. So the law here is, because 3 raised to the power c minus 1 is the same as 3 raised to the power 3, the bases are the same. When bases are the same, are the same, equate powers. And when powers are the same, equate bases. So here bases are the same. We have that c minus 1 equals 3. Add 1 to both sides. This is going to 0. This c is equal to 3 plus 1, 4. 1 minus 1 is 0. So 3 plus 1 is 4. So what that means is, if you are going to check that 3 raised to the power c minus 1 is something as 3 raised to the power 4 minus 1, which is 3 raised to the power 3, which is 27, which is equal to 27. Good. Okay, we take another example. X raised to the power minus 1 over 3 is equal to 1 over 3. We want to find x. We want to get the value of x. How do we do it? First of all, we get the inverse or reciprocal of minus 1 over 3 is, the reciprocal of a number is that number which multiplies the original number to give you 1. So if you have a, what multiplies a to give you 1 is 1 over a, because a times 1 over a is 1. Another one, minus 2 over 3. Its reciprocal will be minus 3 over 2. We have minus 2 over 3 times minus 3 over 2 is 1, minus 1 times minus 1 is what? 1. So here, the reciprocal is not 3 over 1, it's minus 3 over 1. That's one thing that will give you 1 when you multiply the two of them. So we have x raised to the power 1 over minus 1 over 3 equals, okay, times minus 3 over 1 equals 1 over 3 raised to the power minus 3 over 1. What do we have? Minus times minus is plus. So this x, 3 will cancel. X is equal to 1 over 3 raised to the power minus 3, which is what? Change it to positive index. 3 over 1 raised to the power 3, which is 27. 3 raised to the power 3 is 27. So, problems like this, you will often see them. And in the next videos, we will talk about other kind of problems, exponential problems. Don't forget to like, share, and